All right, yeah. Sorry about that. My name is James. This talks about React, Flux, and basically React and Flux on the front end talking to the servers on the back end. We won't go into much isomorphic stuff. I think this is a really good first step for a lot of people. All right, so I work for SitePoint. We're hiring front-end developers now, so if you are interested in doing some of the stuff that you see in this presentation, let me know afterwards. And yeah. So currently at SitePoint, we're trying to React all the things, like all of them. And we started off with a small portion of the application, and it's slowly spreading to more and more of the application. And on the site, on the React site, they mentioned like it's the V and the MVC, but people that use React know that this isn't quite true. But it does do one thing interesting. So this is a quote by Lee Byron, the guy who did MelbJS. Goes, people are like, don't worry, it's just a V. Yeah, that's because we don't need M. We have arrays and objects, because the arrays, the objects, they just get passed into the components, and we output what we need based on what we pass in. But we sort of need more than arrays and objects. Not that arrays and objects don't represent our data fine passing through the app, but we need better ways of passing the arrays and objects around, because data flows through React in one direction. So the actual React structure is a directed acyclical graph. So the data basically comes in and trickles down and never loops back on itself. So the data can only go in one direction. So we need tools and ways of getting that information back up to parent nodes and spread out through the app, or get the information to where we actually need it. Yeah. So enter Flux. So Flux is a way of getting that data to where we do need it. And we, at SitePoint, we've really basically fell in love with it. It doesn't solve all the problems, but it solves most of them. But there's a bit of a learning curve, especially with Flux talking back to the server. So for those that don't know, this is the basic Flux way of thinking. So if we start with the view, view's probably a good place to start, top right-hand corner. The view shows maybe some sort of form, right? And you hit that submit button. That's going to fire off an action and that action is going to take in whatever information it needs or whatever's passed to it, and it's going to put together a payload. It's going to pass the payload into the dispatcher, and the dispatcher is going to distribute the information wherever it needs to go. In this case, the store. And the store is going to get that information, update its internal state, and then let whoever cares about it know that I've changed. It doesn't tell the view or anything else, or derived stores anything about what's changed or anything like that. It just says, I've changed. And it's up to the views or whatever else to basically go, I care about that, and do their own job. So if we go through this a bit more, we'll go into a little bit more detail about Flux essentially first. So the dispatcher, it takes the payload from the actions. It passes the payload to the stores via registered callbacks. So the stores get a chance to register something into the dispatcher, and the dispatcher, when it gets the payload, it basically sends that same payload to every callback that's registered with it. The actions create that payload and pass it into the store. In the code that I'm going to show you tonight, the actions are also going to be doing the asynchronous stuff back to the server. We tried putting the asynchronous stuff back to the server in different places. We tried the stores and the views and having special React components that just did asynchronous stuff, but we found that the actions really work. It allows us to target and send the information wherever we want to go. The stores, they're where the state changes. Flux is heavily based on other paradigms, especially one called CQRS, Command Query Response Separation. And in that situation, you have, so it's more of a back-end thing, but you have basically events coming in, you have aggregators that listen to the events, and then those aggregators build the projection for maybe an API endpoint or some other way of consuming the data. So the stores are, you can think of them as almost being the projections, the ideal state of the app. You should be able to ask them at any point in time, being like, what should I look like? What should I be? How should I act? So in the code that I'm going to be showing in a little bit, there's some little things you should probably know. Basically, what does this stuff look like in the code that I'm going to show? And one thing on the views that's really important is the state function. So the state function is our way of getting the information from the store. So at this, this is all ECMA 6 as well. So if it looks a bit weird, just it's coming soon. You'll see it more often. So the state function that you see there, at the top we're including in our taco store, and we have a function called state. This state function, we should be able to call it at any point in time and get the information that we need for this component to render properly. So in this case, we're returning to the maybe some sort of array or something like that of tacos and a total, which I'd guess is some sort of number. Those store.getAll and those store.getTotal is the only way are functions that are exporting information out of the store, which we'll see a little bit in the code examples of how those come out. So with that, you'll notice that there's no way of putting information back in the store. The only way to put stuff back in the store in the Flux paradigm is through the dispatcher. So to get something into the store, we need to fire call an action that creates a payload and puts that into the dispatcher, and then the store should get it from there. Inside of the component itself, we have the getInitialState. So just quick question, who here has used React? It's probably, all right. So getInitialState, this is just going to quickly take that state function, and it's going to apply it to the state, and it's going to cause, it'll use that for that first render. So we can almost use the state function on that first initial load as like the promise pattern, right? I'm going to give you information, but in the meantime, you should be able to deal with it without that information, right? So below that, we have a little utility update function that's basically going to get the current state and basically set it to the current state, just override whatever's in there based on the current state. We probably don't want to throw away everything else. That's why we're using the set state. Maybe there's some loading stuff or internal stuff that we don't necessarily want to touch. On the component will mount, we're taking the store and we're subscribing to it. And every time the store changes, we're going to call this.update and update the store. We also, if the components go away or stuff like that, we don't want that listener hanging around, so we're pulling it out. Inside the actual render component, we're just going this.state.count. So that should be total. But that would output the total. So dispy was, we started doing this at SitePoint, and we started writing heaps and heaps and heaps of boilerplate. I mean, for every component that you want to listen to something, having those lines there, all those lines, not necessarily the greatest thing ever. So we wanted to remove the boilerplate, make it easy so we could write our stores or fire things into the dispatcher and have our stores or have our components subscribe to said stores. So dispy is the current iteration on that. We're probably about 8 or 9 of these in. But the code examples I'm about to show you use this. It's a very, very lightweight wrapper around the Facebook dispatcher. All it is initializing it, which if you look at any example, does it in, if you look at all the Flux examples, it does it in app dispatcher. It basically does that for you. And then there's some 3 small tools, which we'll go into in a quick second. So the 3 small tools, we have a send thing. This basically takes a string. The send function takes a string and whatever you want to pass into the dispatcher. So the string is a unique identifier. This is going to be how the stores know to act on it or not. Doesn't matter. We're basically sending a payload with an identifier as counter inc and an ID set to the ID. This is ECMA 6 pattern matching for that last ID in the square brackets. So that ID is essentially coming out as that. All right. So we use send to send our payloads into the dispatcher. Our projections are what we use in our stores. So we have singleton stores. We use that. Some people are, if you look at the Yahoo stuff, they're using not singleton, sorry. But essentially, I've pre-filled some data into the counters, given it an ID, or put in one already of ID A, title Bob, count 5. So if we did send counter inc and we did ID of A, that would call in our store the this registered callback down here. So in that registered callback, store.register counter inc function payload, we're taking the ID from the payload, we're grabbing the counter and the count, and we're setting it to the new version. And in this case, this callback is going to call the broadcast out for the components to understand what's going on. The last one is on the components. We needed a better way, instead of writing those get initial state, update, component did mount, component will mount, component will unmount. So we created a mixin that basically takes a state and stores. It's variadic, so you could have the view do the same thing based on multiple stores changing if you really wanted to. So a small little app. We already have a lot of this in the app I'm about to show you. We already have a lot of the stuff sort of there. We're going to add in an additional feature into this, depending on how much time we have. So this is our taco app. It's there for keeping track of how many tacos we eat during a week or day, whatever. It's not really important, but so the main part of our taco app is our store. So our taco store. We've got a tacos object at the top, and that's going to have keys for each individual type of taco. It's easier in this case, for the quick example, to just modify individual types of tacos instead of having them as array, because we don't have to look them up and change them as we do stuff to them. We created a new DSP projection, and we've created 2 registered callbacks. And tacos update, so in that case we're going to take all the tacos that we get and we're just going to fire them into our underscore tacos variable. And in our taco update, we're going to do it based on an ID, and we're going to update a single taco. And and then at the bottom, we're also adding a getAll function to basically return all the tacos. Our app, a little bit more complicated, but the bits that matter is our mixin for subscribing to that state function up at the top, which we're just grabbing those tacos, all that getAll function from our taco store, and just shoving it into the taco property in our state. That mixin is going to take care of updating the component as our tacos change. And down below, we're just grabbing the information from that store and plugging it into children components. So this is the only place, in this application, this is the only place where we have state is coming into this component, and it's the only state lives in the store. Everything else is basically ways of updating that store and then broadcasting out the changes. So if we look at our component did mount, this is the first thing really is how do we get the tacos from the store, those tacos that we already persisted back to the database. And in this case, when this component mounts, we're going to call a poll action. Yeah. How's that? Is that? Yeah. Let me know if you need it even bigger. So on this line here, the component did mount. We're calling tacos actions.poll. Inside of that's essentially calling our poll action, which we abstract out all of our asynchronous calls so that way we can mock them out in our tests. So this is just a habit. But essentially what's happening is this poll is getting the tacos from the server, and then it's going to pass that response into our update tacos function, which we've curried in, and we're going to send a tacos update event into the dispatcher with the response from the API endpoint, which the store is going to get it inside of here and going to set our tacos to that. It's going to broadcast out the changes, and our app will re-render on that. So if we in here type in beef and cheese, that is if we refresh the page, can't actually see it happening, but that is getting that from that call right there, that initial as the component mounts. So our silly implementation doesn't have a way of removing the tacos, right? So we know that our API in this case has a way of dealing with that on the back end. And in our HTTP, we have that abstracted out delete taco function available for us. Does the same thing that we can call inside of our actions. So what we'll do is same thing. So when we delete the taco, it's in the API. I know, because I know what it's going to be doing, is going to be returning all of the tacos. Maybe not the most efficient thing, but for this example, it's a good thing. So, and then we're going to take that payload of all the tacos and just shove it over top of the current state, and which will cause a re-render based on that current state. In our actual taco bit, we need a remove button. So I've already created a component for that. We need to pass in that ID that comes in. No, I shouldn't have to do that. Sorry, I have watch on. So now if we refresh this, we have that little X. But it doesn't actually do anything yet, because our button doesn't call the proper action. So in our remove component, prevent the default from happening on the button, and we're just going to call actions.delete.this, which is the ID that the backend needs. Once again, don't have to do that. Just have it. So now, when we refresh this, when we click that, it goes away. So what we've done, though, is, so if anybody's done React before, normally if you were doing this, you'd have your state up at the top. You'd pass in a callback into the things below to edit the state above, which is, in my mind, really horrible. You're basically passing, if that child component is maybe a couple nested deep, you're passing that same function all the way through and trying to make sure it has that context of the thing at the top, instead of just saying, I want to delete this. And that's what what Flux allows us to do. How much time do I have? That's good? Or yeah. So in this application as well, as we, it is an app for keeping track of how much tacos we eat, and that's not really great. So what we're going to do is we're going to include a count. And yeah. So our count there. But now let's increase the count, right? So the same pattern. We're going to add a button. We're going to create an action for that button to update the store. It's going to do the asynchronous stuff in the action and take the stuff we get back from the back end and send that into the store, and then our view is going to update. So what we'll do is we'll have an inc button. These names are horrible, by the way. This isn't actually what we would call things. An inc button. I need to stop also pressing that key. But now we have a plus button. Once again, it doesn't actually do anything. So what we need to do is inside of our actions, we need to create our inc function, which this is calling our inc function, which does asynchronous action, returns the promise that the response comes in, and then calls the update taco. So the update taco is the singular one. It's going to call that taco.update. It's going to take the taco and it's just going to pass in that taco that we get back. So the API in this case, we give it an ID of what we want to increment, and it's going to return the new version of that taco in total, and we're just going to take that and overwrite that taco inside of the store. So for as memory, so we're going to grab the taco, grab the ID, and assign the new taco to that ID. The register will broadcast out to the view. So, I need to go into the component and turn it on. So in the component, on the click event, we're just calling that action that we're exporting. So that action, our inc action that we're exporting down at the bottom, gets an ID, passes it into the function, gets a response, and then essentially sends that into the dispatcher. So now if we refresh that, it increments, and as we do these things, it will increment. And as so what we found, the biggest benefit of using Flux was, as our application scaled and grew in complexity, as the features came in, we could pinpoint small little flows through the system of data that we could essentially target and abstract out the stores to more manageable ways of dealing with it. So if you've done React without Flux, and if you've created anything like this before, this gets really hairy really fast. Yes, you can do it. Yes, it's no problem. But now picture this is actually nested inside of other components, and those components that deal with that state are nested inside of other components, and it just gets to be a big mess really quickly, where this allows us to abstract it out into small little composable pieces. Yeah, so this demo example, this application that the taco counting app, is available on GitHub at this. I'll get Mark to tweet it out later. If anybody wants that, you can go through the code, have a play with it, run on your own machine. Once again, if you're interested in this stuff and want to be doing this stuff full time, we are looking for new front-end developers at SitePoint. We do this stuff every day. And thank you very much. I'm James Hunter.